In today's video, we're going to use our understanding of Biot Savart Law to solve for the B field at the center of a semicircular loop with the uniform current I. We have our Biot Savart Law here, and what we need to identify is our dl cross r. So if we were to write on our semicircle, we can say that this is our r vector. And we can say that dl is a little chunk of our arc length, dl, which is completely tangent to the arc itself. So no matter which part of the arc you are on, we get a 90-degree angle here. That's 90 degrees. So since we have dl vector cross r hat, we can say that the magnitudes of these, since they're cross product, will equal d magnitude dl vector times the magnitude r hat, or the unit vector, times sine theta. So our r hat, our unit vector, is equal to 1. And if we look at our drawing, we see that because dl and r are 90 degrees, that's what our theta would be. So then we end up getting sine 90, which is also equal to 1. And then our dl can be defined in terms of r d theta. R d theta is the arc length of our circular loop, whereas r vector is a distance vector defined from the current element to the point the B field is being calculated. So if our B field is right here, then our r vector is the distance away from our element, or our current, up here. Okay? So now that we have our r d theta, and we know that all of this is equal to 1, we end up getting dB vector is equal to mu naught over 4 pi times I r d theta over r squared. So the reason why I'm able to write r squared here is because we have our r vector going in as r vector, which is equal to negative r times r hat. So our r is non-changing, it's constant for every point on the arc. Okay? And we can say that the radius r is opposite the value of our r vector. Okay? So because of this, we can say that our r for our Biot Savart law is r squared. Okay? So now we just want to do the integration. So we can write b, the B field, is equal to mu naught I over 4 pi r, the integral from 0 to pi d theta. This whole integral will give us a value of pi, and then we just multiply that into our B field. So what we end up getting is we get the B field is equal to mu naught I over 4 r. And then, if you noticed, I canceled out an r on top and an r on bottom. So that was done here in this step. So I crossed one of the r's out. And that's why I only have a singular r on the bottom right here. I want to reiterate that the r vector here has the same length as our radius. So that's why we're able to relate our little r with big R for this problem. Okay? Lastly, we want to find the direction of this magnetic field. So if we observe which direction the current's going, in this direction, I, then we can say, using the right-hand rule, that the magnetic field is going like this. It's curling around this wire as such. So what's happening is the magnetic field is coming out of the page at the middle of our circular loop. All right, so using the right-hand rule, we determine that our B field is out of the page. And we can just denote that here with a circular dot, out. Okay, so now this is our final answer using Biot Savart Law, and that's how we find the magnetic field using the law.